Hello viewers, today's topic is primary geometry. First subtopic is point. Point is a fundamental geometric element with no size or dimension represented by a dot in a coordinate system. It is the basic building block for defining lines, shapes and objects in geometry. The key point is it has no dimension, that is, it has no height, no length, no breadth, etc. Now come to lines. There are two types of lines. Just a minute. There are two types of lines. Curved line that has no fixed direction, and another is straight line. It does not change its direction. It has no endpoint. Its symbol may be written like that, AB, and if on the line there are 2 points A and B, then in between A and B, the part of this line is known as line segment, that is AB bar. Okay. Next, ray. What is ray? Ray is a portion of a line that extends infinitely in one direction from a fixed point. That is, a ray has one endpoint. As you see here, the O is the endpoint and another side is endless. It has no endpoint. This is ray, and this may be symbolized as OA, like that. If the arrowhead is like that, then this ray can be symbolized as O A sorry OA. Okay. But if this is like that, then it can be symbolized as A O. Understand? Now I can repeat again. A straight line is a continuous arrangement of points extending infinitely in both directions. This is known as straight line. What are the parallel lines? Now, types of lines. I come to the types of lines. First of all, parallel line. Lines in the same plane that never intersect. This is known as parallel line. The distance between two lines is always constant. These two lines say L1 and L2. L1 parallel L2. Say two lines are like in the figure, lines that intersect at a right angle, that is 90 degree, known as perpendicular lines. The angle in between two lines is 90 degree or a right angle. That is why these two lines L1 and L2 are known as perpendicular line, and perpendicular line is symbolized like that. Parallel line symbolized like that, and perpendicular line symbolized like that. Here L1 perpendicular to L2. What is intersecting line? Lines that cross each another at a common point. This is known as intersecting lines. L1 and L2 are the intersecting line. They are intersect each other at point O. So it is intersecting lines. This is perpendicular lines, and this is parallel lines. Another type is, I am writing here, transverse line. This is transversal. Transversal. A line that intersects two or more other lines is known as transversal. Say these are two lines, L1 and L2, and L3 intersects line L1 and L2, then L3 is the transversal of L1 and L2. For a circle, a line touch a point of a circle, then this line known as tangent line. Tangent line. There are so many other lines also, but we have to consider these types of lines according to our necessity. Okay. So we understand what is point, different types of lines, ray. Okay. Now the point, angle. What is angle? If you see the figure of an angle like that, see here, from point O, ray OA is produced, and similarly from point O, OB ray is produced. Okay. Therefore, when two rays having common endpoint make an angle, say this is theta, angle theta. So an angle has a vertex here O, point O, and two arms and two arms. What are the two arms? Here ON and OB are the two arms. Here O is the vertex, point O is the vertex, and here OA and OB are the two arms of the angle, and this angle can be represented as in symbol like that, AOB. Okay. So when two rays having common endpoint make an angle. Now we are coming to the types of angle according to the measurement. First of all, zero angle. Say two rays overlap each another, then the angle known as zero angle, because in between two rays OA and OB, the measurement of angle is 0. That is why this is known as zero angle. Okay. And what is acute angle? An angle measuring less than 90 degree and greater than 0 degree is known as acute angle. What is a right angle? An angle exactly equal to 90 degree is known as right angle. And what is an obtuse angle? An angle measuring more than 90 degrees but less than 180 degree is known as obtuse angle. What is a straight angle? An straight angle equal to 180 degree forming a straight line. So straight line looks like straight angle. This is straight angle. Straight angle looks like, right? And obtuse angle looks like, this is an obtuse angle. 90 degree. This is right angle. Acute angle. This is acute angle. Okay. And now come to the reflex angle. An angle measuring more than 180 degrees but less than 360 degrees is known as reflex angle. This angle is reflex angle, more than 180 degree but less than 360 degree. Now come to the point, complete angle. What is a complete angle? An angle equal to 360 degrees forming a complete circle known as complete angle. If two rays, common point O, one ray is OA, another ray is OB. If OB ray rotate like that and complete 360 degree, then this angle known as complete angle. The value of complete angle is 360 degree. It may be noted that maximum measurement of angle in geometry is 360 degree, whereas minimum measurement is 0 degree. So, an angle in geometry minimum 0 degree and maximum 360 degree. The value of an angle in geometry is in between 0 degree to 360 degree. So, for a geometric angle, theta, the value of theta less than equal to 360 degree, more than equal to 0 degree. Okay. There are so many types of angles apart from these types. Now, I am discussing about these types. First of all, interior angles. Angles from inside a polygon determined by extending sides are known as interior angles. Okay. Say, for a triangle ABC, the angle A, B, and C are the interior angle. These three angles are interior angle. Whereas for a triangle A, B, C, if we produced BC to D, then we get the exterior angle ACD. If we produced CA to E, then we will get the exterior angle of A, right? And if we produced AB to F, then we get exterior angle of B. So, if we naming like that, then A dash, C dash, and A dash, B dash, and C dash are the exterior angles of this triangle. Okay. And angle ABC, angle A, angle B, angle C are the interior angles of the triangle ABC. So, angles formed inside a polygon are known as interior angles, whereas angles formed outside a polygon adjacent to its sides are known as exterior angle. Now, I am coming to adjacent angle. Which one known as adjacent angle? It is very interesting. Angle AOB and angle VOC are the adjacent angle. So then what is its property, main property? There are three properties by which we can decide it either a pair of angles is adjacent angles or not. What are these properties? Number one, common vertex. Common vertex. If two angles have a common vertex, then it will cover a property of adjacent angles. Here, two angles, angle AOB and angle BOC, have one common vertex, that is O. Right? Second property is one common arm. They have one common arm. Here, OB is the common arm. Common vertex is point O, common arm is OB. Right? And thirdly, if two angles satisfied that one is not overlapping to on another, then these two angles are adjacent angle. So, if two angles satisfied these three conditions, then they are adjacent angle to each another. If two angles like that one is angle AOB and another angle is AO. See, this pair of angles satisfied point property 1 because of these two angles have one common vertex O. Similarly, these two angles satisfy condition 2 also. They have a common arm OA. AOB and AOC, for these two angles, the common arm is OA. But these two angles do not satisfy the third property, that is, they are overlapping each other. So, angle AOB and angle AOC are not adjacent angle. I hope you are understand adjacent angle. Now come to the complementary angles. If two angles like that then they are called complementary angle. Meaning of that? Nothing. If the sum of two angles is equal to 90 degree, then they are complementary angle. Very simple. Theta 1 plus theta 2 equals to 90 degree. So, if theta 1 given 30 degree, then theta 2 will be 60 degree if they are complementary angles. Now come to the supplementary angle. Supplementary angle, if sum of two angles, theta 1 plus theta 2, is equals to 180 degree, then these two angles, theta 1 and theta 2, are known as supplementary angles. So, if the value of theta 1 is 50 degree, then the value of theta 2 will be 130 degree if they are supplementary angle. So, theta 1 and theta 2 makes a straight angle because sum of theta 1 and theta 2 is 180 degree. It is to be remembered that supplementary angles makes straight angle. Now, vertical opposite angles. If two lines intersect each other at point O, then four angles will be created, and these opposite two angles are known as vertical opposite angles, whereas these two angles are also vertical opposite angles, and these are always equal. Okay. Pair of opposite angles formed by intersecting lines, they are equal in measure and known as vertical angles. Now, I am discussing about the corresponding angles, alternate interior angles, and alternate exterior angles. To demonstrate these three types of angle, I have to draw two straight lines and one transverse. What is a transversal line? I already discussed. So here two lines, line 1 and line 2, and the transversal line, line 3, makes 8 angles: 1, 2, 3, 4, 5, 6, 7, 8. First of all, angle 3, angle 4, angle 5, and angle 6 are interior angle. Interior angles, because of they are situated in between two lines, L1 and L2. Similarly, we can say angle 1, angle 2, angle 7, and angle 8 are the exterior angles. Okay. Now corresponding angles. Angles in similar positions at the intersection of two lines when a transversal cuts them are known as corresponding angles. Angles in similar position. Look here. Angle 1 and angle 5. They are in similar position. So, angle 1 and 5 are the corresponding angle, and they are also situated in one side of L3. Similarly, angle 2 and angle 6 are the corresponding angles. Okay. They are also are in same side of L3. These are the corresponding angles. Now, pairs of non-adjacent interior angles on opposite sides of a transversal are known as alternate interior angles. Non-adjacent angle. Here, 3 and 4 are the adjacent angle, 5 and 6 are the adjacent angle. So, 3 and 5 pair 3 and 5 and 4 and 6, angle 6 are the pair of alternate interior angle. Because of angle 3, angle 4, angle 5, angle 6 are all interior angles, and 3 and 5 are not adjacent angle, as well as not adjacent and opposite side of the transversal L3. Similarly, angle 4 and angle 6 are also non-adjacent and opposite to the transversal L3. So these two pair of angles are known as alternate interior angles. Okay. What are the alternate exterior angles? Angle 2 and angle 8. Look here. Angle 1, 2, angle 7, angle 8. These four are the exterior angle. In between, among these four angles, angle 2 and 8 are the exterior angles, but they are opposite to the transversal. So, angle 2 and 8 as well as angle 1 and 7 are the pair of exterior angles. I hope you are understand corresponding angles, alternate interior angles, alternate exterior angle. Now come to the central angle. Which one is known as central angle? An angle whose vertex is the center of a circle with its sides intersecting the circle is known as central angle. So, to demonstrate central angle, I have to draw a circle and indicate the center point. Then this is the central angle. Okay. This is O, A, B. Angle AOB is the central angle. Now come to inscribed angle. An angle formed by two chords in a circle with its vertex on the circle is known as inscribed angle. This is inscribed angle. Inscribed angle A, B, C. This is inscribed angle. Now we come to the point line of symmetry. If a line divide a figure exactly in two equal halves, then this line is known as line of symmetry. Here these lines, any of these line divide this circle in equal to halves. Then these lines are known as line of symmetry. For a circle, there are infinite number of line of symmetry. But for a rectangle, there are only two, these two and these two, that is, four lines are line of symmetry. Now, we will find the sum of interior angle of a polygon. Sum of interior angles of a polygon. It is very easy. But before that, we have to know one thing, that is the sum of interior angle of a triangle is equal to 180 degree. That is angle A plus angle B plus angle C is equals to 180 degree. We know that triangle is the polygon in which minimum sides are there. That is three number of sides in a triangle and make a polygon. Here in a triangle there are three angles, angle A, angle B and angle C, and the sum of these three angles are 180 degree. Then we can easily find the sum of interior angles of a polygon. Say I draw a hexagon. There are six sides, that is why it is named as hexagon. This is the center point. If we add all vertices to the center point, then we will get six number of triangle. So all angles, sum of all angles in this figure is equal to 6 into 180 degree, because of there are six triangle and each triangle has sum of interior angle 180 degree. So the sum of all angles in this figure is equal to 6 into 180 degree, that is 1080 degree. But But the sum of interior angles of this hexagon is excluded these 6 angles, and these 6 angles makes 360 degree. So 2 into 180 degree equals to 360 degree will be deducted from 1080 degree, and we get 270 degree. So sum of interior angles of a hexagon is equals to 720 degree. Similarly, we can find for a pentagon. Five into 180 degree, that is 900 degree, and this angle to be excluded, 2 into 180 degree, that is 360 degree. If we subtract 900 360 degree from 900 degree, then we will get 540 degree. Similarly, for a quadrilateral, 2 into 180 degree, to be subtracted from 4 into 180 degree, that is 720 degree, and we will get 360 degree, right? So in general, see here, number of sides minus 2. Here also number of sides minus 2. Here also number of side minus 2 into 180 degree is the sum of the interior angle. So if we formulated the sum of the interior angle, then we have to write like that: if the side of a polygon is n, then 2 is to be subtracted from n, and it will to be multiplied by 180 degree. Then we will get the sum total of interior angles of a polygon. So it is the general formula. In this context, we have to remember that the sum of exterior angles of any polygon is equals to always 360 degree. Okay. These 2 points, interior angle, sum of interior angles of a polygon and sum of exterior angle of a polygon is to be noted. Now another 2 interesting things I am going to discuss. This is number of diagonals. Number of diagonal of a polygon. What are the diagonals of a polygon? Say it is a polygon. Here are 5 sides, so it is a pentagon. Okay. And what are its diagonal? If we join 2 vertices here, A, B, C, D and E, 5 vertices. So if we join any 2 vertices, then we will get either a side of this polygon or a diagonal. So if 2 vertices are joined, then other than sides of this polygon are known as diagonals. So BE is a diagonal. Similarly, BD is another diagonal. Okay. If we take C vertex, then CA, CE are another 2 diagonals. So now you will understand that what are the diagonals. Now I'll discuss about how do we find the number of diagonals of a polygon. It is very easy. From n vertices, we have to take any 2 vertices. The combination is NC2. The polygon which has n vertices, it has n sides. N sides are not the diagonals of this polygon. So n to be subtract from this number, NC2 minus n. This is the number of diagonal. Okay. If we simplify this equation, then we will get NC2, that is factorial n divided by factorial n minus 2 into factorial 2 minus n. Then factorial n equals to n into n minus 1 into factorial n minus 2 divided by factorial n minus 2 into factorial 2 minus n. Factorial n minus 2 to be eliminated, and we get like that. Factorial 2 equals to, we know, 2 into 1 minus n. So this is equal to n into n minus 1 minus 2n divided by 2 equals to n square minus n minus 2n divided by 2 equals to n square minus 3n divided by 2 equals to n by 2 n minus 3. So a polygon which has 3 sides, that is n equal to 3, then number of diagonal nd equals to 0. Because of n minus 3, that is 3 minus 3 equal to 0. So whole thing is 0 and number of diagonal equals to 0. It is for triangle. Okay, because a triangle has 3 sides. For a quadrilateral, n equals to 4. So nd equals to 4 by 2 into 4 minus 3, that is 2. For n equals to 5, number of diagonal equals to 5 by 2 into 5 minus 3, that is 5 by 2 into 2, that is 5. Okay. For hexagon, n equal to 6. So number of diagonal equals to 6 by 2 into 6 minus 3, that is 3 into 3 equals to 9. I hope you are understand the procedure to find out the number of diagonals. Now, another important relation, that is f minus e plus v equals to 2, where f, e, v are the standard notation. F is the number of face of an object, e is the number of edge of an object, and v is the number of vertices of an object. Then the relation between face, edge and vertices will be f minus e plus v equals to 2. Let a object cuboid is taken. Let us take a cuboid, then we easily can tell that the number of vertices equal to 1, 2, 3, 4, 5, 6, 7, 8, and number of face equals to 1, 2, 3, 4, 5, 6, and number of edge equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we put f minus e plus v If we put the values in f minus e plus v, then we will get 6 minus 12 plus 8, that is 14 minus 12 equals to 2. So this relationship is proved for cuboid. Similarly, for other objects, this relation will be satisfied. And how do you remember this relation? It is very easy. The second month of English calendar is February. If we write February, Feb, like that, FEV, instead of, in place of B, you have to put V, then the left side part of this equation will come. And the second month of English calendar. So, second, that is 2, will be equal to FEV equals to 2. Now, the signs. It is also easy to remember. Before F, there is plus sign. After F, minus sign. After E, plus sign. So, plus, minus, plus. Now, the full relation you can remember in this way. F minus E plus V equals to 2. Okay. At the end of this video, in point number 10, I am just naming some figures like triangle, which has 3 sides, that is known as triangle, and quadrilateral, quadrilateral, it has 4 sides. Quadrilateral has 4 sides. When two sides of a quadrilateral are parallel, then this is known as trapezium. Two sides are parallel. This figure is known as trapezium. When opposite sides are parallel, then this is parallelogram. Opposite sides are parallel. Okay. Then when an angle is equal to 90 degree of a parallelogram, then this is known as a rectangle. If one angle of a parallelogram is 90 degree, then all other angles are also will be 90 degree, and this figure is known as rectangle. When the all sides are equal of a rectangle, this is known as square. A rectangle which has all sides are equal, then this is square. When a square has no right angle, then this is known as rhombus. Rhombus has all sides are equal, all sides are equal, but it has no right angle. Okay, this is rhombus. When adjacent sides are equal, then the figure is known as kite. Okay, so if we revise this part, then we will get triangle has three sides, quadrilateral has four sides. If a quadrilateral has two sides are parallel, then this is known as trapezium. If opposite sides are parallel, then this is parallelogram. If one angle is right angle of a parallelogram, then this is known as rectangle. If all sides of a rectangle is equal, then this is known as square. When a square has no right angle, then this is known as rhombus. Rhombus is not a square because it has four sides are equal, but it has no right angle. When a quadrilateral has adjacent sides are equal, then this is known as kite. This figure are to be remembered to solve our mensuration problems. Each and everything has application in mensuration. So the primary geometry is to be clear first of all, then you will face efficiently the mensuration problems. Okay, so in this video we have discussed about point, line, types of lines, rays, angles, types of angles. Okay, and then we discuss about the line of symmetry, sum of interior angles of a polygon, the sum of exterior angles of a polygon, number of diagonals of a polygon, and the relation in between face, edge, vertices of an object, and finally the different types of figures or fields like triangle, quadrilateral, trapezium, parallelogram, rectangle, square, rhombus, kites, etc. Thank you. Thank you very much.